Right then, just to show this off one last time, I kid you not, this is less than 2 minutes after the last video, I reckon, this one. And I've just changed the program again so the lights flash. I'll show you that. So if I turn the indicator on. So you can see they're sort of running lights just running all the way outwards, which I quite like that effect. On and off. And on. And off. Oh, I just love it. Love it. Good stuff. I'll tell you what, if anybody is interested, the next video then I'll show this all done and fitted on the bike with a bit of luck. I'll show the program that I wrote and the wiring as well. So if anybody wants to have a go at doing this themselves, it doesn't cost a lot. These chips, I think I got, I can't remember how much they were now. They were cheap as chips, these things were. Cheap as chips, literally. But yeah, I will, oh, now you see. I've just been completely thrown off what I was saying because someone just walked in the door.
I've come to the door. Is everything okay?
Everything's okay. How was it? Was it good?
Good.
Look at the time, 10 to 12. This is my oldest daughter's just come in. Say hello.
Is that what's going on or not? I don't know. You've been here like creating the whole time.
Creating the whole time? Yeah, but look what I've created. Look, watch this. Watch this. Watch this. Face of amazing.
I'm drunk enough that's impressive right now.
No, but watch. Yeah, but watch. You ready? You ready?
Yeah.
Come on, watch. Put your hat on. Put your drunk hat on.
It's tangled up, okay.
You ready? Ready?
I'm ready.
Ready? Watch. Ready? Go.
Whoa, blind. That's quite nice, actually. Oh my god.
How's that? Time for bed. Come on. Go to bed.
It's time for bed. That's where I'm going right now.
Well, good evening once again. Back on the bike a little bit today, which has been quite nice. So nothing's changed out here. I haven't really done anything out here. I've got hold of some chokes. Now they're both just sitting there, so I don't lose them. But they will be fitted. The idea of these, just some little manual chokes, so I don't have. I'm trying to reduce the amount of stuff I have around here, so I'm going to get rid of the two choke cables by doing this, which is a bit of a result. Good stuff. So we'll fit those. Not yet though. We're still doing the indicators. So that's inside then. Let's go and have a look. Let's go and have a look. So this is where we are. Good stuff. So we are doing these running indicators on for the front, which is going to sit underneath the fairing, as we saw. Well, I'm sure we've seen already at some point or other in the videos, if you've seen any of the other ones anyway. Okay, so now just a quick rundown of what's happened here then. This is done now, nearly done anyway. So, first off, one of my mates bought me one of these. Now this is a little Arduino Uno. And I read up on it, and it's a little programmable chip, and I thought, that is fantastic. I want to use that somehow in the bike. So I sort of investigated, I thought, right, you know what? I'll be able to figure out the indicator of that. Got involved a little bit more with it, and then I was going to build one control unit to control the whole bike. Having a chat with somebody else, they said, actually, if you're going to do the whole bike, this really isn't very good, because you need something that will do more than one program at any one time. And they suggested an Arduino Duo, which is one of these. So I bought this. With all great intentions of actually doing the whole bike, all of the wiring, all of the electrics and power and everything from that unit there. But when you start thinking about all of the wires involved, there's an absolute crap load. Imagine these indicators. Look, there's 7 LEDs down each side. So there are 14 separate LEDs. Each one would have to be powered. So that would be 14 wires. I need a power and an earth as well, so that would have been 16 wires. And then you get the idea, when you start adding up these, running all of those wires from front
So you come back to work
to back would be a right pain in the arse and just unnecessary, really. Okay, so did away with that idea, and then I got myself one of these, which is an Arduino Nano. Now it does exactly the same thing as that thing over there, but it's tiny. Okay, and my theory with this was, well, if I put that in here, actually in this unit itself, all I need coming out of this unit is 4 wires: the power, the ground, and 2 indicators. So indicator switch left and indicator switch right. And I've done it. I've made it now. If you look, I've got 4 wires coming out of there.
I'm not going to sleep with you.
And that everything here is all internal in there. Now this looks right messy at the minute, but give me a chance. This is the first controller I've ever made. And I've run out of hot glue as well. I'm waiting for some more hot glue to come so I can glue all of this in and make it all sealed. Okay, so I'll show you it working in a moment. But if you want, we can have a look at how it's actually done. Now there's 2 parts to this. There's the wiring circuit itself and the program itself. So I'm not showing you the best way of doing this. I'm just showing you how I did this. And if you wanted to have a go at it, you should be able to follow what I've done pretty much and be able to have a go yourself. But I'm going to do this all ad hoc, so I might ramble on and repeat myself a lot of times. So bear with it if you want to. If not, turn over now. I'm sure there's something better on the other side anyway. Okay. So first off, what should we do first? Wires or program? Wires, program. Let's have a look at the program. Whoop. So this is a basic programming thing with the Arduino. So you go in and you type different things in here. You then get a USB cable, plug it into your Arduino, and you push the arrow up here, and it forces the data across into the chip. Now you'll have to forgive me as well. I've lost my bloody phone holder somewhere, so it's going to move around a bit, I'm afraid to say. Oh, that's typical. Typical. We've got 7%. We better make this quick, haven't we? Right. So now this is a very, very quick rundown of my program. So all I've done in the first instance, then, and this won't make sense to you maybe if you haven't looked at an Arduino, but when you do, it will make sense. So all I've done is I have told it what everything is. So if you look at this, pin number 2 is a switch in, pin number 3 is a switch in. So you have a certain amount of digital pins and a certain amount of analog pins. And then the val and the val 1 are validation, so that it's going to look at these in a little while. And then I've told it what all of my all of my pins are. So I've got a lot, if you look. I use up all of the digital pins and then 4 of the analog pins as well. And the analog pins do exactly the same as the digital pins anyway. Okay, and then I tell it what they are. So are they an output or are they an input? So I've got 2 inputs and a shitload of outputs. And then here, if you look at this, right, val 1, read the input. If it equals low, then do the following. Switch LED pin A1, A2, A3, A4, digital pins 4, 5, 6 to low. So switch all of one side off. And that's what it's doing. It's switching one side of the indicator off here. And then with the other side, turn one on, wait 70 milliseconds, turn the next one on, wait 70 milliseconds, turn the next one on, wait 70 milliseconds, so on and so forth. And so we can change our delays here, we can change our order, we can do anything. It's absolutely stunning, this thing, I'll tell you. So what it does is it turns them all on one side, and then it reverses, holds them on for 200 milliseconds, and then it starts switching them off in order as well. If you see what I mean. Now, so that was if valve 1 was low. If it's high, then it needs to switch all of these to low. And these are the ones that it was switching up there a minute ago. Okay, so then if valve is low, then it needs to switch off the other side. Now these are the LEDs that we've just been switching on. So it switches them all to low. And then if you look, it does the same thing. It just goes high, 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 high with a delay. And then switches them all off, low, 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 and so on and so forth. If val equals high, then switch everything off. And that's it. You know, again, there must be a prettier way of doing it than this, I'm sure, a more simple way of doing it, but this works absolutely fantastic. It didn't take long to figure out how to do this, to be fair. And if you wanted to, you could actually just copy what I've just done and it would work. There you go. Hey, just while we did that first, that's just died now. Fantastic. Okay, so that's that. Now then, are we going to be able to do this without shaking around too much? Basically then, if you can live with this, now I'm going to ramble here, I know I am. I'll tell you what, I might go and have, let me go and have another look, see if I can find my phone holder. Bear with me. Okay then, so I can't find my holder, so you're sat on top of the magnifying glass at the minute, so I don't know how this is going to look. But let's see then, and you'll love this. Look at this. This is the last thing that we ordered. This is a piece of 3mm thick bit of brass. I think you'll like this. You'll like that bit. Some of you will anyway, for sure. But that's for another video. Right, okay. So wiring, let's have a look at this wiring now. Now this is all about current really and voltage. The LEDs work off of 12 volts and they need around about 180.
Oh my god, is that Pete's Place 55?
Yes, you know it.
The baddest YouTube channel about.
You know it.
I'm such a fan. When are you going to Comic-Con? Are you making an appearance at somewhere in the
Yeah, do us a favour. Can you just go?
I've triggered him, guys, go. You know. Oh, sorry, guys.
See you later. Have a good time. Right, the LEDs, 12 volt, 180 milliamps. Now, 180 milliamps, I don't know about 180 milliamps, but I measured, they were pulling it around about 180 milliamps, but they were feeding around they had about 14 volts going to them. But anyway, let's say that's what it is, 12 volts, 180 milliamps per LED, remember. And I have 7 of them. Now they won't, well there's 14 altogether, only 7 will run at any one time, but even so, 7 running at a time. And I am going to change the program in the future so they all run, and this is for something totally different. But we'll worry about that when we get there. So potentially anyway, I might have 14 of those running. Now 14. Well, let's do 7. 7 times 180. 1, 2, 6, 0. Good. So if all of them are running on one side alone, it's going to pull over an amp. That's 1.2 amps there. Okay. Now then, where is my nano? This little nano that we're going to use it outputs 5 volts. And each pin can only carry 40 milliamps. And I think, I can't remember the spec in total, but I'm sure in total, the amount of current in total is maxed out at 200. So you can appreciate the values here are way out. So this is not going to be able to power the LEDs without getting some other components involved as well. Fair enough? This one here as well. I'm a little bit worried about how well this is all going to last with the vibration of the bike, but we don't, we won't know until we. I'm going to turn the telly down a little bit. we won't know until we try it. You know, it might fall apart in 5 minutes. These, I got these off eBay. I think I bought something like 5 of these for about 12 quid or something ridiculous like that, which is just as well. I toasted about 3 of them. But yeah. But anyway, this can't carry the amount of current that we need to power those, so we need other things involved here. So we are going to use something called a transistor then. Okay, so page 2. Let's wire this bad boy up. Get rid of that. So here's my Arduino Nano. Here is my LED, and we have to wire the two together. Okay, so this Arduino has 12 volts feed, and it has a ground as well. So a ground, actually it's got 2 grounds. It's got one either side. So I've got 2 grounds and a 12 volt feed going into this Arduino. I also have to have 2 switches. So one for left indicator and one for right indicator, and we'll come back to those again in a minute because they're a bit of a pain. Okay, so they're my indicators, left and right. Left, right. And if you remember the program, it said if when it was looking for what was going on, it was looking for low. Low is 0, low is ground. So these are switching to ground when it turns the indicators on. Okay, so then I have 14 outputs coming out of this thing as well. Now we only need to draw 1 output. Okay, but the rest of them are all exactly the same. So I have an output coming out here that when I switch it on, it goes 5 volts. So it switches high, switches 5 volts on. I then have one of these. Yeah, you can see the packet. See what they are maybe. This is an NPN transistor. NPN. And if we get one out, they're tiny little things. However, these have, if you go back and look at the packet again, these have, or they can carry 200 milliamps. Okay, or something, or just over 200 milliamps. So they are powerful enough to run one of these. Still with me? Right, this NPN then, which is that one there, has 3 legs, as you can see. One of them is the base, which is going to go onto here. Okay, one of them is the collector, which is going to go up to my LED, and the other one is the emitter, which is going to go down to ground. Okay, so this is my transistor basically fixed in as it is. Okay, now the current coming out of here, we want to reduce this current as much as possible. So what we've done is we've put a resistor in here. Okay, and the resistor, that resistor is 1.5 kilo ohms. So this one here is 1.5 kilo ohms. Can you see that? Yeah, good. Now, I also, because these weren't switching off properly, so what I had to do as well is I had to put another resistor from here down to ground. Okay, and this one was actually 12 kilo ohms. Now these resistor values, they don't have to be exactly what I've put down, they just have to be around about that figure. The idea is to get the right one here which means that you can carry enough current up to your LED without carrying too much current through here. Now these transistors have something like 100-to-1 ratio or something ridiculous like that. So I'm looking at, across here, I'm looking at, I don't know, 1 milliamp, maybe 2 milliamps, something like that. So virtually bugger all, really. And that's it. And then my LED here has a permanent 12-volt power supply. And it works. It works bang on. So when this pin goes high, it switches on this transistor and it allows current flow on this line here. And it allows enough current flow that this lights up nice and brightly, gets all of the current that it needs. Okay? So that's one. Now, going back to these ones over here, they were a bit of a pain in the ass. It did say, I'm going to move you a little bit. Now, bear in mind what I'm doing here then, I have basically this is just going to go to my indicator switch, which on the other side of the indicator switch I'm going to have ground. So when I switch it on, ground goes in. Now, they do have something called a pull-up resistor in these, which when the line or when the pin isn't at ground, it should be sitting at 5 volts, but for some reason it doesn't seem to work on here. So I had to put my own pull-up resistor. And basically what that means is I had to put another resistor off of each one of these lines to 5 volts. And one off of here as well. So one resistor going off to 5 volts. Now it wasn't too much of an issue because one of these pins on the Arduino is a 5 volt output anyway. So basically I just put a resistor link from one of those down to the 5 volt and another one from there down to the 5 volt. And I put a huge resistor, I put 80 kilo ohm or something I put in there and it worked fine. Okay. And what that does then is when this... So here is our circuit. Pretty much anyway, I think 12 volts in, ground in, going to the Arduino here, up out to the LEDs and that as well. Indicator switches left and right, and then I've got some 80 kilo ohm resistors between these lines and back to the 5 volt pin. And the resistor size here, I've got 12 kilo ohm resistors coming out from the base to the negative. And then I've got a mixture of 1.3s and 1.5 kilo ohms coming from the base back to the Arduino to the switch pins on the Arduino. Brilliant. And it works. Like I say, it might not be the best way of doing it, but it works. Now then, I don't, I've learned an awful lot doing this. This is brilliant for me. I could not have done this without the help of Marcus. So Marcus, if you ever watch this video, mate, you're a genius. Thank you very, very much indeed. Okay, so now then, let's have a look at it working. So I've just put it inside here at the minute. And as you can see, I've only got 4 wires coming out. One's going to positive, one's going to negative, and then I'm left with these 2 here, which are indicator switches. And let's have a look and see. So you can see this one. So my flash in sequence, as you can see, is going out and then back in again. Sort of pulsing out. And then the other side is same thing. And you can see it flashing out and flashing back in again. Now the reason I've got the fair in here, if you bear with me, let me just connect this one up so it keeps going. Try to, one-handed, this will work, no problem there. Well, good afternoon. This is the next day from that very moment there, and I just frazzled Arduino number 5 then. When I lifted it up to the fairing, I've got some bare wires on the thing, and I must have shorted one of the wires against one of the output pins or something like that, or one of the volts, because I had it still connected to the battery. Killed it. So now then, this is the last Arduino I have. I've actually ordered some more, but I ordered a whole load of them all in one go. This is my very last one. But for the price of them, I've ordered some more because I'm going to use them elsewhere. So now then, I will just show you it working on here then. Okay, so if I go 4 wires coming out, as you can see. If I go to ground here, right indicator. Good. Works fine. I'm going to get the other one. And I go to ground with this one. Good. Working fine. Okay, so there you go. It's all working fine. I'm not going to put this in the fairing and show you it working in the fairing because I need to insulate all of this and I need some hot glue so I can get it all sealed in there and stuck in there how I want to get it stuck in there. So like I said, I think this is another bit that's half done. I will put this video up just because, well, just because it's raining outside and I can't be asked to do anything else. Okay, so we will get on and do something a bit more useful in a little while, but for now, we're done. I'll see you soon.